A battleship is a large warship with a main battery consisting of large caliber guns. It's true that battleships are no longer being used in naval forces globally, but they are still seen as a marvelous piece of engineering. Battleships were mainly used for shore bombardment tasks, provide air defense to protect carrier task forces, and sometimes, though not very common, even attack enemy warships. But since the development of cruise missiles and anti-ship missiles, using battleships near shores was no longer an option, because a ship that big would be a sitting duck for anti-ship missiles. There have been many great battleships built throughout history, like the HMS Dreadnought, which was laid in 1906 and revolutionized the way battleships were built. The Japanese Yamato and the German Bismarck are some of the largest battleships ever made, in addition to the American Iowa Class, which consisted of 4 battleships: Iowa, New Jersey, Wisconsin, and Missouri. There were plans to build 2 more, but they were cancelled later on. Today we're going to take a closer look at Iowa Class battleships. We're going to cover some of their technical specs, in addition to a general overview of their operational history. The rising desire to dominate the Pacific led the US and Japan to constantly upgrade and increase their naval capabilities. And part of US's plan to face the rising Imperial Japanese Navy is to build a new class of battleships, and this would later be the Iowa Class. During the years between World War I and World War II, the US made a series of joint Army and Navy board war plans for dealing with a possible war with Japan. These plans, which were known as Plan Orange, tried to anticipate what the US would face in case that a war between Japan and the US breaks. Planners of the war foresaw that the US fleet would be engaged in the Central Pacific, progressing with an extended communication and logistics network that could potentially be targeted by swiftly maneuvering Japanese cruisers. The primary concern lay in the fact that the traditional 21-knot battle line of the US Navy might not be sufficiently fast to compel these Japanese task forces to engage in combat. Meanwhile, the swifter carriers and their cruise escorts would be at a disadvantage against the upgraded Japanese Congo-class battle cruisers, which had been converted into fast battleships during the 1930s. Consequently, the US Navy formulated a strategy involving a rapid detachment of the battle line, aiming to draw the Japanese fleets into confrontation. Even during the design phase of the preceding North Carolina class and South Dakota class battleships, concepts that could achieve speeds exceeding 30 knots to counter the threat posed by agile big gun vessels were seriously taken into consideration. Simultaneously, there was a vision for a specialized strike force of fast battleships operating alongside carriers and destroyers. Such force could function autonomously in forward regions and serve as reconnaissance units. Over time, this concept evolved into the fast carrier task force. Initially, the carriers were perceived to be subordinate to the battleships. Design studies of the Iowa class began in early 1938 under the direction of Admiral Thomas C. Hart, head of the General Board. Studies included designs for slow battleships with a speed of 27 knots with enhanced armament and protection, as well as fast battleships capable of reaching speeds of 33 knots or more. One of these slow designs was an expanded South Dakota class carrying 12 Mark 6 16-inch 45 caliber guns or 9 18-inch guns with more armor and power. Preference was given to the fast design to counter and defeat the 30 knots Japanese battle cruisers of the Congo class, which had higher speeds than the existing US battleships. The width constraint of the Panama Canal also played a role in choosing the design. Among the fast battleship designs, a specific design pursued by the Bureau of Construction and Repairs Design Division aimed to create a battleship optimized for countering cruises. This initiative, led by Captain A.J. Chantry, commenced on January 17, 1938, resulting in blueprints for ships featuring a total of 12 16-inch and 25-inch guns. These vessels were designed to adhere to Panamax dimensions while maintaining unrestricted displacement. Their performance specifications included a top speed of 35 knots, a range of 20,000 nautical miles at an efficient cruising speed of 15 knots. This blueprint effectively fulfilled the outlined criteria, resulting in a ship with a standard displacement of 50,000 long tons. However, Chantry posited that larger dimensions could yield even more advancements. With a displacement exceeding that of most battleships, the proposed armor would only provide protection against the 8-inch weaponry typical of heavy cruisers. Towards the close of January, 3 enhanced designs labeled as A, B, and C were formulated. Shared features among the 3 versions included an increase in draft, extensive augmentations to the armor, and the substitution of 12 6-inch guns in the secondary battery. A was the largest of the trio, at a displacement of 59,000 long tons. It retained the 12 16-inch guns within 4 triple turrets. The variant necessitated 277,000 shaft horsepower to achieve a speed of 32.5 knots. On the smaller side, B displaced 53,000 long tons. It shared the same top speed of 32.5 knots as A, yet required only 225,000 shaft horsepower to attain this velocity. Furthermore, B carried 9 16-inch guns distributed across 3 triple turrets. Meanwhile, C closely resembled B but incorporated an additional 75,000 shaft horsepower, bringing the total power to 300,000 shaft horsepower to fulfill the initial requirement of 35 knots. During March of 1938, the General Board endorsed a fresh design inquiry that concentrated on enhancing the dimensions of the 35,000 long-ton South Dakota class. Initial plans for this endeavor suggested that achieving a speed of 30 knots was viable with a standard displacement of about 37,000 long tons. Pushing for 33 knots necessitated 220,000 shaft horsepower and a standard displacement of roughly 39,000 long tons, significantly below the London Treaty's maximum escalator clause limit of 45,000 long tons. These blueprints managed to convince the General Board that a reasonably balanced and well-designed fast battleship capable of 33 knots was attainable within the parameters of the escalator clause. However, subsequent examinations uncovered major issues with the estimations. The speed of the ships meant that greater freeboard would be required for both fore and amidships, with the latter necessitating an extra foot of armored freeboard. This change introduced additional weight to support these new requirements. The ship's structure needed reinforcement, and the power plant had to be expanded to prevent a decline in speed. Altogether, approximately 2,400 long tons needed to be added, and the substantial margin the Navy designers had initially believed they had, around 5,000 long tons, diminished. Moreover, the draft of the ships was permitted to increase, allowing for a narrower beam and reducing the necessary power. This adjustment also facilitated the shortening of the ships, which led to weight reduction. The General Board was surprised to find that increasing the tonnage by 10,000 long tons would only lead to a modest 6-knot speed improvement compared to the South Dakota class. The original plan was to use the 16-inch Mark 6 guns from the South Dakota, but it was decided that the design should incorporate the more powerful but heavier 16-inch Mark II guns. These Mark II guns were initially intended for the shelved Lexington-class battlecruisers and early 1920s South Dakota-class battleships. The 16-inch turret, which housed the Mark II guns, was heavier by about 400 long tons compared to that of the Mark VI. This added around 2,000 long tons to the ship's weight, exceeding the 45,000 long ton limit. A potential solution was a preliminary design from the Bureau of Ordnance for a turret that could accommodate the 50 caliber guns while fitting the smaller barbette of the 45 caliber gun turret. Other weight reductions were achieved by using lighter armor and substituting constructions steel with special treatment steel in specific areas. This brought the preliminary design displacement down to 44,000 long tons. However, a miscommunication occurred between the Bureau of Ordnance and the Bureau of Construction and Repair. The former developed the larger barbette turret, while the latter integrated the smaller barbettes into the contract design. This incompatibility was realized only in the final refinement stages of the contract design. By then reverting the 45 caliber gun or adopting the larger barbette turret was impractical due to the design modifications and weight issues. To resolve the situation, a new 50 caliber gun, the Mark 7, was developed by the Bureau of Ordnance. It was lighter and had a smaller outside diameter, making it suitable for the smaller barbette. This redesign led to an 850 long-ton weight reduction in the Iowa class's overall design. As a result, the contract design displacement was set at 45,155 long tons and 56,088 long tons at full load. In May 1938, the Second Vision Act was passed by the United States Congress, requiring a 20% boost in the strength of the U.S. Navy. This act, sponsored by Carl Vinson, a Democratic congressman from Georgia and chairman of the House Naval Affairs and Armed Services Committee, updated previous acts from 1934 and 1936 that had authorized the construction of the first American battleships in 17 years. These earlier acts were based on the terms of the 1930 London Naval Treaty. President Franklin D. Roosevelt promptly approved this act, providing the necessary funding of approximately $100 million per ship to construct the Iowa Class Battleships. As 1938 came to an end, the contract design for the Iowa Class was nearly finished, but it underwent ongoing changes during the final detailed design conducted by the New York Navy Yard. These modifications included adjustments to the foremost four-mast design, replacing original 1.9-inch or 75 caliber anti-aircraft guns with 20mm 70 caliber or Lincoln cannons and 40mm 56 caliber Beaufort guns, and relocating the Combat Information Center within the armored hull. In November 1939, the New York Navy Yard made significant alterations to the internal subdivision of the machinery rooms in response to tests indicating insufficient underwater protection in those areas. Enhancing the longitudinal subdivision of these rooms resulted in better flooding resistance and reduced openings in the third deck. Although these changes added weight and slightly increased the beam, the concern over exceeding the design limits diminished because Britain and France abandoned the Second London Naval Treaty when World War II began. The design displacement reached 45,873 long tons standard. By the time the Iowa Class battleships were commissioned, the incorporation of increased anti-aircraft armaments, additional electronics, and enhanced crew accommodations raised the standard displacement to about 47,000 long tons, while the full load displacement expanded to 57,000 long tons. The four ships had a length of approximately 270 meters, a beam of 33 meters, a draft of 11 meters, and displaced a standard of 45,000 long tons and about 58,000 long tons at full load. Similar to other battleships, the Iowas were heavily armored to protect them against shells, bombs, and torpedoes. The designers of the battleships used a concept called the all or nothing, which was prominently recognized for its applications on dreadnought battleships. The all-or-nothing principle focuses on robustly protecting vital ship areas while leaving the remainder of the vessel unarmed. This concept deliberately shunned the use of lightly or moderately thick armor, opting for armor in substantial practical thickness or none at all. This approach ensured a distinct contrast, comprehensive shielding or minimal defense in comparison to prior armor schemes. Ships adhering to the all-or-nothing doctrine featured thicker armor concentrated on a smaller portion of the hull. The protection system of the Iowa class included a combination of Class A face-hardened crop cemented armor and Class B homogeneous crop type armor. Additionally, a significant application of special treatment steel or STC, a high-strength structural steel, possessing armor-like attributes akin to Class B, was integrated into the hull plating to enhance safeguarding capabilities. The Iowa Class Battleships also had heavily protected main battery turrets featuring 19.5-inch Class B and STC facing, 9.5-inch Class A sides, 12-inch Class A rear, and 7.25-inch Class B roofing. For the propulsion, the Iowas were equipped with 8 Babcock and Willis boilers and 4 sets of double reduction cross-compound geared turbines, each linked to a single shaft. General Electric provided the geared turbines for Iowa and Missouri, while Westinghouse supplied those for New Jersey and Wisconsin, generating 212,000 shaft horsepower. The power plants enabled speeds of up to 32.5 knots at full load displacement and 33 knots at normal displacement. Carrying 8,000 long tons of fuel oil, the ships could travel up to 15,900 nautical miles at 17 knots. Now, before we talk about the armaments, we need to talk about the targeting systems that the Iowas used. Before the digital revolution and warships started using digital targeting systems to accurately locate their targets, battleships like the USS Iowa used electromechanical analog computers to do that. There are mathematical equations that describe the motion of a projectile, but adjusting the guns in real time means solving these equations, which have a lot of variables to take into account, so solving them manually is not an option. And this is where fire control computers like the Ford Instruments Mark 1A fire control computer and the Mark 8 Rangekeeper step in. Firing guns accurately from a moving ship is a challenging task due to factors like changing ship motion, wind, and target distance. For naval vessels, accurately hitting targets requires complex calculations considering these variables, especially when targeting distant objects. Ships at sea often encounter rolling and pitching, complicating aiming even more. Iowa Class battleships employed 2 targeting systems, the Mark 8 Rangekeeper for the 16-inch gun and the Mark 1A fire control computer for the smaller 5-inch gun. These mechanical analog computers could handle complex calculations involving variables like wind speed, ship speed, and Coriolis effect in real time, predating digital computers. These variables could be input manually or automatically. Once locked onto a target, the system transmitted signals through a switchboard to the gun turrets, maintaining proper aim and adjusting gun elevation for the ship's movement. The Mark 8 was electromechanically networked, combining 5 analog computing hardware boxes into one unit. Even after the modernization of the battleships in the 80s, the Mark 8 Rangekeeper remained the targeting system for the 16-inch naval gun. For smaller guns that were targeting faster aerial objects like planes, more complex calculations were needed. The Ford Instrument Mark 1A fire control computer was employed for this task. It proceded inputs from gun directors and accounted for parallax between the director and the guns. It calculated fuse times for shell explosions and was considered accurate for anti-aircraft operations. However, it had limitations, particularly against high-speed aerial targets like jets. The Iowa Class battleships are some of the most heavily armored warships the United States Navy has ever deployed. The initial configuration of the battleships consisted of a main battery, a secondary battery, and an anti-aircraft battery. The main battery consisted of 12 16-inch Mark 7 guns mounted on 3 turrets. The Mark 7 was the largest naval gun to be mounted on a U.S. warship. These guns could fire a 2,700-pound armor-piercing shell or a 1,900-pound high-explosive shell with a maximum range of about 23.6 miles. Each of the 3 turrets weighs over 2,200 tons, 2 in front of the ship and 1 in the back. The Mark 7 naval gun was a powerful and accurate weapon. It was known for its significant range and destructive capabilities. The armor-piercing shells fired from these guns can penetrate concrete layers of almost 9 meters. The high-explosive shell had the capability to generate a counter with dimensions of 15 times 6 meters. While positioned off the coast of Vietnam, USS New Jersey occasionally launched a high-capacity shell into the forest, resulting in the creation of a helicopter landing area spanning 180 meters in diameter and causing deforestation of an additional 270 meters beyond that perimeter. Even after the modernization of the 4 battleships in the 80s, the Mark 7 remained as the primary gun of the battleships. A version of the W-19 nuclear artillery shell was developed specifically for the 16-inch gun, which was called W-23, making them the world's largest nuclear artillery shells, and making the Iowa Class Battleships the only US Navy ships ever to have nuclear projectiles designed for them. The W-23 was a nuclear artillery shell designed from the W-19 nuclear artillery shell, which was fired from a special 11-inch howitzer. The W-23 was specifically designed for the 16-inch gun. The W-23 had a yield of 15 to 20 kilonewtons of dynamite. 50 shells were produced between 1955 and 1962, and luckily none of them were ever fired. The secondary armament consisted of 20 5-inch Mark 12 guns. These dual-purpose guns can hit stationary targets up to 9 miles away, as well as aircrafts at closer range. The 5-inch gun was one of the best dual-purpose guns of World War II. First developed in the 1930s to equip new destroyers, the 5-inch was used on almost all major US warships built between 1934 and 1948. It was also used in support ships, merchant ships, small warships, and ships of the United States Coast Guard. The gun had a high rate of fire and ability to load easily at any elevation angle, both highly desirable qualities in an anti-aircraft weapon, and the introduction of the proximity fuse anti-aircraft shell in 1943 made the weapon even more powerful and effective. The anti-aircraft weapons of the 4 battleships evolved over time because of the evolution of air threats, from air raids in World War II to higher jet speeds after the war. The Iowas initially had 20 quadruple mouths for Bofors 40mm guns, for a total of 80 barrels distributed along the main deck and the superstructure, with a firing rate of up to 160 rounds per minute and a range of 11,000 yards. Moreover, 49 single or Leacon 20mm guns were distributed throughout the lower 5 levels of the superstructure and main deck, with a firing rate of up to 450 rounds per minute and a range of 4,800 yards. The operational history of the Iowa-class battleships is characterized by their service in various conflicts and roles throughout their careers. The 4 battleships of the class Iowa, New Jersey, Wisconsin, and Missouri saw action in World War II, the Korean War, the Vietnam War, and the Gulf War. USS Iowa was commissioned in February 1943 under the command of Captain John L. McCree. Her early missions included countering the German battleship Attribuites and carrying President Franklin Roosevelt to conferences in 1943 at Cairo and Tehran, where he met with Stalin and Churchill. She also brought Roosevelt back to the United States, and because of this, she was nicknamed the Battleship of Presidents. Iowa operated in the Pacific, supporting airstrikes against Japanese bases and participating in major naval battles. In the Battle of the Philippine Sea, she helped repel Japanese air raids and contributed to the destruction of Japanese carrier-based aircraft. She continued to provide naval gunfire support and participated in operations throughout the war. In the Korean War, Iowa was recommissioned to support United Nations and South Korean forces with her powerful guns. She provided shore bombardments and remained engaged in the conflict. New Jersey had an active service record in World War II, participating in major campaigns and battles in the Pacific. She supported carrier operations, bombed Japanese bases, and played a pivotal role in battles like the Battle of the Philippine Sea and the Battle of Leyte Gulf. In subsequent years, New Jersey served in the Korean War, and she was the only 4 Iowa battleships to serve in the Vietnam War, and also participate in various trainings and operational missions. USS Wisconsin was part of Admiral Halsey's 3rd Fleet during World War II. She engaged in air raids on Japan and provided escort carrier operations. Wisconsin was involved in the Korean War and participated in the Gulf War after a period of recommissioning and modernization in the 80s. Missouri, the last of the 4, joined the war in the Pacific in 1945, participating in air raids on Japan and hosting the surrender ceremonies that ended World War II. She later served in the Korean War, providing naval gunfire support and engaging in combat operations. Missouri also experienced periods of decommissioning and recommissioning, serving as a museum ship and being reactivated in the 80s. Overall, the Iowa Class battleships played crucial roles in various conflicts, showcasing their firepower and versatility. Final recommissioning. As part of President Ronald Reagan's Navy Secretary John F. Lyman's effort to create a 600-ship Navy, the 4 Iowas were reactivated. The ships then underwent a modernization process to make them ready for modern-day warfare. During the modernization, the Iowas had all of their remaining Oerlikon 20mm and Bofors 40mm anti-aircraft guns removed due to their ineffectiveness against modern-day jet fighters and enemy anti-ship missiles. Over the next several months, the ships were upgraded with advanced weaponry. Among the new weapon system installed were 4 Mk141 quad-cell launchers for 16 AGM-84 Harpoon anti-ship missiles, 8 armored box launchers, ABL mounts for 32 BGM-109 Tomahawk missiles, and a quartet of the United States Navy's Phalanx Close-In Weapon Systems (CWIS). The battleships also received 8 RQ-2 Pioneer drones. This replaced the helicopter that had previously been used to spot for the 16-inch Mark 7 guns. By 1992, the 4 Iowa battleships were all decommissioned and turned into museum ships, and with their decommissioning ended the era of battleships for good. This was the video. Thanks for watching. If you liked it, please do like and subscribe. If you wish to support us, I will leave my Patreon link in the description below, and see you the next time.